Hello guys, welcome back. So here we have another question on network theory from GATE EC 2015. At very high frequencies, the peak output voltage V0 in volts is dash. So this is the circuit they have given. And they're asking us to find at very high frequencies. So they haven't stated at what frequencies, right? And then this is the V0 we need to find. So one thing you need to remember, for a capacitor, what is your impedance looking like? Your ZC will look like 1 by SC, right? Or in frequency domain, it is 1 by j omega c. So as omega tends to infinity, your ZC becomes 0. On the other hand, for an inductor, your ZL is SL, which is j omega L. And as omega tends to infinity, your ZL becomes infinity. So it's like an open circuit. This is like a short circuit. So when omega tends to 0, what happens to ZC? At DC, what happens? It is infinity and it acts like an open circuit. So for DC, the cap is open, and at very high frequencies, the cap is almost short. Similarly, for an inductor, at DC it is open, sorry, at very high frequency it is open. At DC it acts like a short circuit. So this we already know, right? So now we just need to short these and find the voltage V0. So here we can put a short, here it is short, and then this is also short. So what we'll get, we'll have sine omega t here, it is short, 1 kilo ohm, 1 kilo ohm, these both are short, 1 kilo ohm, 1 kilo ohm, and then we have this also a short, and this is your V0. So from this only you can directly say the top resistance and bottom resistance are equal, so V0 will be 0.5 sine omega t. So V0 peak is equal to 0.5 here. Okay. On the other hand, if you have capacitors in series, let's say sine omega t, something like this in somewhere in the circuit, right? And this is 100 microfarad and this is 200 microfarad. So in this question, all the capacitors were equal, but here the capacitors are different. Then how will your C1 and C2 vary? So if you always see, your ZC is inversely proportional to your C. So when ZC is lower, or in other hands, when C is lower, your ZC will be higher, and the voltage across that ZC should be higher, right? Because for the same current flowing through it. So in this case, it might divide as 1 by 3 sine omega t. Here it is 2 by 3 and here it will be 1 by 3 sine omega t. So this is plus minus plus minus. So you can also think like when you pump the same current, the charge deposited on each cap is same. And if you remember, your voltage is nothing but it is Q by C. So your voltage is inversely proportional to C. So higher the cap value, lower is the voltage change. Similarly, lower the cap value, higher will be the voltage change. So this also you should keep in mind. For the inductor, it will be the other way around. Okay. So for this question, the answer is 0.5.